Okay, let's review the subspace null space. Null space and column space. And the most difficult part for difficult problem of this part is how to find the basis of null space and column space. First, we review the definition of subspace. What is subspace? If a vector set U satisfy two conditions. The first condition is if U with two vectors belongs to the bigger U, the capital U, then U plus V belongs to U. That is the addition of two vectors still in the U. The second if U belongs to the capital U, then multiply the U by any number is still in the U. The lambda belongs to R. So if we want to determine a vector set is a subspace or not, we just need to check these two conditions. The second definition is null space and column space of a matrix. The null A is defined as all vectors x such that ax equals 0. And the column space of matrix A, that is the span of, we call maybe A1, A2, AN. If A equals A1, A2, its column vector are A1, A2, and to the AN. That's the column space. The most difficult part is how to find the basis of column space and null space. Maybe the null space is a little easier because we just need to solve the system AX equals 0. We did that before. We use example to show how to find the basis of null space and column space. The first step is still the same, that we need to do the row reduction to change the matrix to be its reduced row echelon form. Suppose A is matrix 1, 1, 2, 2, 1, 0, 2, 1, 5, negative 1, and 2, 0, 3, negative 1, 3, and 1, 1, 0, 4, negative 1. Find basis of null A and column A. column space A. After we get the reduced row echelon form of A, then we can write the null A and column A directly. How to do it? So first, A equals 1, 1, 2, 2, 1, 0, 2, 1, 5, negative 1, 2, 0, 3, negative 1, 3, and 1, 1, 0, 4, negative 1. We reduce this to the, we use row reduction to reduce this matrix to be its reduced row echelon form. The reduced row echelon form. First, we multiply the first row by -2, then add to the third row, and then multiply the first row by -1, then add to the fourth row. The first row multiply by -2 and add to the third row. This is 0. This is -2. And here is -1. It's -5. This is 1. And the fourth row minus the first row, 0, 0, -2, 2, -2. 4 minus 2, -1 minus 1, that's -2. Yeah. And 1, 1, 2, 2, 1, 0, 2, 1, 5, -1. And the third row, add the second row, that is 0, 0, 0, 0, 0, 0, 0, -2. And we can divide the fourth row by -2, that is 1, -1, 1. And exchange the third row and the fourth row to write all the 0 row at the bottom. 0, 2, 1, 5, -1, 0, 0, 1, -1, 1, 0, 0, 0, 0, 0. This form is row echelon form, but it is not the reduced row echelon form. This is the row echelon form, but now we can find the column space right now. What is column space? Find the column space. Now we can write the column space as a span of its basis. After we got the row echelon form, each pivot number or pivot position correspond to the basis of vector. The first pivot position is at the first row, so the first vector in the A is in the basis 1, 0, 2, 1. And the second pivot number or pivot position is on the second row, second column. So the second column in A is in the basis, and the third position is at the third column. So is 2, 1, 3, 0. That's the basis. These three vectors are the basis of column space. These three vectors are basis of column space, just determined by its position, pivot position. But there is some other problem not directly cannot solve directly from the row echelon form. So we use row reduction to reduce it as reduce the row echelon form. Now the third pivot number is 1, and the numbers above it are not 0. We change those numbers to be 0. So the first row subtracted the third row. The third row times -2. Here is 2. So times -2 and add to the first row. So 1 is times -2, add to here, and this is 4 times -2. This is -1, and the second row subtracted the third row. So that's 0, 2, 0. That's 6. That's -2, and 0, 0, 1, -1, 1. 0, 0, 0, 0, 0. And the second row divided by 2, and it's 0, 1, 0, 3, -1, 0, 0, 1, -1, 1. Yeah, 0, 0, 0, 0. And okay, we got column space now, and we use the next step. The first row subtracted the second row. That's 0, 1, 0, 0. That's 1. That's 0, 0, 1, 0, 3, -1, 0, 0, 1, -1, 1. That's reduced row echelon form. Now we can find the null space. First, the ax equals 0. The solution of ax equals 0 we got by this. If we write this matrix, the corresponding linear system of this matrix, that is x1 plus x4 equals 0, and x2 plus 3x4 minus x5 equals 0, and x3 minus x4 plus x5 equals 0. Actually, we can write the solution directly. Use a faster method to write down the solution. We talked this before in the first video. That is -1, 0, 0, -1, the x3 and x4 and x5 are free variable. For x4, we write x4 as 1 and x5 is 0, and x5 here is x4. x4 is 0 and x5 is 1. When x4 is 1, x1 is -1, and x2 is -3, and we mentioned before that just change the sign of this number. the first this one is corresponding to x1, so change the sign as -1. And the second number is 3, corresponding to x2, so that is -2 for x2. And this -1 corresponding to x3, so here is 1, change the sign. And now for the x5 equals 1. The x corresponding, this 0 corresponding to 1, so here is 0. This -1 corresponds to x2, so that is 1. We need to change the sign. And this one corresponds to x3, so it's -1. So the column, the null space is span because x4 and x5 are arbitrary. -1, -3, 1, 1, 0, and 0, 1, -1, 0, 1. So these two vectors are bases of null space. These two vectors are bases of null space. So actually, if we want to find the null space and the column space, we just use we just reduce the matrix to be the reduced row echelon form. We use row reduction. Now, sometimes it will be asked to find the expression of the bases. For example, we need to find A4. The column space is A1, A2, and A3. How to find the expression of A4 in terms of A1 and A2 and A3? That's actually very easy. There's number 1, 3, -1. The 1 corresponds to x1. So for the first, because this vector is A1 is the first vector plus this the second vector times 3 plus minus the third, the fourth, the third vector. Because the row reduction does not change the relation with vectors, so we have the relation of these four vectors is the same as these four, A1, A2, A3, A4, have the same relation. So A4 is A1 plus 3A2 minus A3. Just use this 3 number. This 3 number is the coefficient of the basis, or the coordinate of the basis. And A5 is negative A2 plus A3. We can check. Negative A2 plus A3. Negative A2 plus negative A. So that's -2 minus 1 is 1. 1 minus 2 is -1, and 0 minus 1 is -1. That's right. So for any problem with matrix, we'd better to reduce the matrix to be reduced row echelon form, because the reduced row echelon form is the simplest form for a matrix, and many problems can be solved directly from the reduced row echelon form.